Good morning. Let us discuss about reference electrodes. So, what are reference electrodes? So, before going to discuss about reference electrodes, let us discuss about periodic table. So, periodic table, we know the metals are arranged or the elements are arranged in the increasing order of their atomic number. So, if we know atomic number, we know atomic weight. So, we have the atomic weight of hydrogen. We know atomic weight of oxygen is 16. Atomic weight of carbon is 12. Atomic weight of fluorine is 35.5. So, how come we know atomic weight of fluorine is 35.5, oxygen is 16 or carbon is 12? So, did anybody weigh the atomic weight of oxygen? No. But as just comparison of atomic, that is comparison of weight of oxygen or chlorine or carbon, any element with that of hydrogen. Chlorine weighs 35.5 times more than hydrogen. Carbon weighs 12 times more than hydrogen, and oxygen weighs 16 times more than hydrogen. It's just a comparison. So hydrogen is taken as a reference and we have arranged, that is the reference. Of course, we have the experimental proof also, but that is the reference. Similarly, when electrodes are also, we have reference electrodes. So with reference to so and so electrode, the potential of this is so much. With reference to so and so electrode, the conductivity of the solution is so much. Then what are these reference electrodes? So this reference electrode should be standardized. So the potential or this electrode should not depend upon the concentration of the solution which is dipped in. It should not depend upon the temperature, pressure of the surroundings. So what are such electrodes? So reference electrodes or the electrodes with reference to which electrode potential of other electrodes can be calculated or determined are known as reference electrodes. I repeat, the electrodes with reference to which electrode potential of other electrodes are determined are known as what? Reference electrodes. We have two types of reference electrodes, primary reference electrode and second reference electrode. Primary reference electrode was used to determine the electrochemical series. Electropotential of all the metals was determined using primary reference electrode, and is using that electrochemical series was framed. So what is this primary reference electrode? Example, standard hydrogen electrode. The standard hydrogen electrode contains platinum metal connected to, dipped in a solution containing H plus ion concentration of 1 molar, and it was inserted with a bulb, and hydrogen gas was passed, which was stored at 1 atmospheric pressure. So as days passed by, the concentration of hydrogen used to change, and it's very tedious process to maintain hydrogen gas as 1 atmospheric pressure. If there is pressure change or the concentration of H plus ion changes, the standard hydrogen potential is to not be zero. The potential is to change. So because of this, we drifted to secondary reference electrodes. So what are the second reference electrodes? Any electrode potential of these electrodes are known and are constant. And electrode potential of these electrodes have a wide range of temperature and pressure. And the electrode potential of these electrodes will not depend upon the concentration of the solution in which it is dipped in. So this is the important feature of our secondary reference electrodes. So now we have two types. We have the example for the second reference electrodes. It might be Calomel electrode, silver chloride electrode, ion selective electrodes, etc. Okay, we have different types of second reference electrodes. Metal ion, metal salt ion, ion selective, etc. So one such example, let us take Calomel electrode and let us see the construction and working of this Calomel electrode. So calomel, what do you understand by calomel? Mercurous chloride. Commercially, it is known as calomel. So let us see the construction and working. So the calomel electrode consists of a glass tube with a side tube. At the bottom of the glass tube, we are going to place mercury. So above the mercury, we are going to place, it is covered with mercury and paste of mercury and mercurous chloride. The platinum metal is dipped in mercury and is connected with copper wire for external connection. The entire glass tube is filled with KCl solution of known concentration. this is the construction of the Calomel electrode. This Calomel electrode can be used, it will act either as anode or cathode depending upon with the electrode which with it is coupled with. The Calomel electrode, whatever we have constructed, it will act either as anode or cathode depending upon the electrode which with which it is coupled with. So if it acts as anode, what are the electrode reactions? If it acts as cathode, what are the electrode reactions? Let's see. So whatever the KCl is filled, it is of known concentration. It is very, very important. So if the electrode acts as anode, then mercurous chloride, if the electrode acts as, the reaction is reversed here. If the electrode acts as cathode, then it accepts 2 electrons and it gives 2Hg plus 2Cl minus. If the electrode acts as anode, then mercury undergoes oxidation to give mercurous chloride and 2 electrons. Okay, the reactions is reversed here. If the mercury acts as cathode, Hg2Cl2 plus 2 electrons accepts electrons to give 2Hg and 2Cl minus. If mercury undergoes, if Calomel electrode acts as anode, 2Hg, that is mercury, will undergo oxidation to give 2 electrons. So as I told you, the electrode potential, the Calomel electrode is a single electrode, right? The electrode potential of the Calomel electrode is given by E equals E naught minus 0.0591 log concentration of Cl minus. So as I told you, the concentration of KCl is very, very important. So here the electrode potential of Calomel electrode depends upon Cl minus ion. As the concentration of Cl minus ion changes, the potential also will changes. So if you are using 0.1 KCl in the Calomel electrode, then the Calomel electrode potential will be 0.334 volts. It will be fixed. If you are using 1 normal KCl, then the Calomel electrode potential will be 0.28 volts. And if you are using standard KCl solution in the Calomel electrode, then the Calomel electrode potential will be 0.2422 volts. So let us see the advantages of this Calomel electrode. It is very simple for construction. The potential is reproducible and stable over a long period of time. Its electrode potential will not vary with temperature. That is the major advantage of the second reference, all second reference electrode. If not Calomel electrode, for all second reference electrode, it is common. So it is commonly used as a second reference electrode for all potential measurements. So any electrodes will have advantages as well as disadvantages. Let us see the disadvantages of the Calomel electrode. So it cannot be used in presence of oxidizing and reducing agents. So it cannot be used in oxidizing or reducing agents. The upper limit of the electrode is pH 8 and it needs to be used freshly. So applications. So used to determine potential and pH so it is used to determine pH. You know that in a potentiometric estimations we are going to use your standard Calomel electrode. It is also used in determination of pH, that is when combined glass platinum electrode is not there, we are going to use Calomel electrode as the reference electrode and glass electrode as the indicator electrode. So it's most of the potentiometric estimations Calomel electrode is used to determine estimate any of the potentiometric, any of the redox reactions. It is also used to determine the pH of the solutions. In olden days when pH meter did not exist, we used to combine the Calomel electrode with glass electrode and determine the potential. Then we used to determine the pH. So these are the applications of the Calomel electrode. Okay. Thank you.